All right, we'll go ahead and get started for today. Thank you all for joining. We have a great office hours set up today. It's going to be tailored toward wrangling all of us data and analyzing it, seeing how it's set up in long format and kind of how to work with it and advance it into your analysis. Before we get started, just want to mention that if you have any questions during the presentation, to go ahead and you can unmute and ask them when there's a pause, or feel free to put them in the chat at any point, and we'll try to answer those like as we're going. And then another quick reminder, our next office hours will be in 2 weeks on August 6th at the same time. So without further ado, I'll introduce our first speaker. Brandy Mapes is going to start us off with the presentation.
Hi everyone, first happy Friday. Thank you so much for joining us. And so like Gage mentioned, we have a topic today that we put together based off of some feedback and some questions we've received over on our support team lately, particularly with regards to how our data is structured, both conceptually and then what that looks like operationally in the workbench. So I'm going to present alongside my colleague Francis, and we'll first just kick it off with a general overview of the topic and some things that we think would be helpful to know. And then Francis will go through some demos of tips and tricks, and then we'll open it up for some general questions. So let me go ahead and share my slides. Okay, let's see. All right, can everybody see that? All right, great. So we went over topics. We talk about major components of all of us data management. We'll talk specifically about long format, which is how our data is structured, both conceptually how it's represented with some visuals, and then we'll go into our demo. So first thing, just for some context and background, we're going to go through some examples using a variety of the different data types available on the researcher workbench right now. This includes participant completed surveys, electronic health record data, physical measurement data, and some wearable device data that is collected through Fitbit. I think we have some information in our support hub, but just in general, this data is collected and then that goes through a process. It's stored in our raw data repository, and then it undergoes a process of curation where it then gets stored and deposited into our workbench. So what you all are looking at is our curated data repository that's accessible through the workbench right now. So just some general things that are good to know. The data in the workbench is accessed through Google BigQuery. This is a serverless multi-cloud warehouse used for our storage. It is selected and exported into a Jupyter Notebook following two mechanisms. You can use our suite of tools. This would be the cohort builder, concept set selector, and data set builder to create your cohort, select your concepts of interest, prepare your data set, and import. That's the method that we recommend. It's really set up with our structure in mind. You also have the option to direct query the CDR through Jupyter Notebooks using SQL. And the part where we're really going to focus on today is the structure. So data is structured in long formats. You can think about this as one row equals one response or recorded entry of data per item per participant. And this is really set up this way just given the longitudinal nature of our study. So we want to collect data upwards of 10 years for our participants. In terms of EHR data, in some cases, we have data that goes back for that entire participant's lifetime. So we want to have a nice way for you to see that repetition and that change over time in this format. So let's talk first through an example using survey data. I think this is probably the one where we've gotten a few questions on so far. So if you think about our surveys, there are certain items in that library that are formatted as select all that apply types of questions. So this is where a participant can select more than one item per question. So let's say you're using the cohort builder, you want to import concepts from our surveys into your data set. Just to give you a look of what we're talking about in terms of long format, you can see here on the screen that your rows are set up according to your participant ID, as well as those response options. So in this example, you have 6 rows of data that are associated with only 2 participants. 3 rows per participant. Each row represents an individual response option that was captured. And I think just to kind of provide some context, I think this would be how this could be formatted conceptually in wide format. And I think where some of our questions have been is, I want my data to look like this. And Francis is going to walk through some of those examples a little later. But so just to give you an example, the previous slide is how that's going to look like when exported. This is a resulting figure, if you're interested in this wide format, of what that would eventually look like, where things are collapsed. Another example we can use to think about this is with EHR-derived height data. So let's say you're using the tools, you want to pull into your data set all entries recorded in the EHR of a participant's height. So let's look at an example here. And by the way, these are this is all synthetic data, just an FYI for sharing purposes. So you're seeing here in long format, you have multiple rows associated with the same participant, and this represents each individual entry of height recorded in the EHR stored as individual rows. So the thing here that I think is important to note is for each individual entry of a concept in those records, it's going to be its own row. And I think what would be really important, or where we've gotten some questions, is how do I collapse this down? And one thing that we always want to note to people is this is going to be so specific to your own project and your own interest. For example, you could collapse that down depending on if you want a mean or a median of a response. You might also want to collapse that in a way that you have individual entries recorded across that same row. So this is going to be really specific to your own interest, your projects, your concepts. Another example we can use to think about this is the Fitbit data. So let's say you want to look at heart rate summary data using our tools. You can see a resulting format where you have 9 rows of data. Again, each row is associated with a single participant. These represent every entry, recorded entry of this heart rate summary for that participant that's available in the CDR. So I think just to summarize what we thought might be the impression we want to leave you with is, you can transform these into wide format if that's your preference, using R or Python for a script. We considered ways that we can help with this process through something like a code snippet, but because it's going to be so specific to your own project needs and considerations, it's really, there's not a one-size-fits-all approach. And so Francis is going to walk through some of that. I will say this was sort of a fun topic for us to do, even as a team, because I think we learned that we all, even on our team, have our own preferences and different ways of handling this. For example, in my past experience, I thought of this as wide format. Francis is used to the long format. So we do recognize that this is, for some people, this is totally the way to go. And for others, they want some tips for making it feel a little more manageable. And so that's all I have. So Francis, I'll go ahead and pass it over to you to walk through some examples.
Thank you, Brandy. Happy Friday, everyone. And before I begin, do you guys have any preference between R or Python to do this presentation? You can just drop in the chat whether you want R or Python. And okay, I see a lot of Python, so I'll go with Python. Does everybody see my screen?
Yeah.
All right, thank you, Brandy. So basically all the talk that Brandy said earlier is because we had a lot of questions. Are the data duplicated, or how do we combine different data types? For example, we have measurements, we have a survey, we have demographics. How can you combine those? Or how do we get one row per participant for data? Because usually researchers are used to this kind of format where for each row you have one person ID and you have the demographics and you have something like, for example, here we have height and weight. So it's just one row per participant. Now with the all of us, so whether in your workflow, whether you're using the tools or you are writing your own queries, the tables are in different, the data are in different tables. So for example, even for the electronic health records, you have the data for the conditions, you have data for measurements, you have data for other, the labs, for drugs, for procedures. So all those different data types are in different tables. And not only that, but Brandy already showed us that it's also in a long format, meaning that if you go to a doctor, for example, they measured your height today, that's in a one row. You go again next week, or anytime you go there, they measured your height again, that's in a different row. So you have all of those rows, and it's how do we get here, which is most of the time if people are doing some, usually, for example, simple regression, and then this is the format that they want. So we want not only to collapse the data in some ways, but combine all these different data types. But how do we do that if the data are in long format? So here, I extracted some data. So basically in this particular thing, what I did is I simplified this a little bit and I just collected demographics data. So the demographics data is in the person table. And I collected the birth, race, gender, ethnicity, and sex at birth. And I limited this for people aged between 25 and 48. And the reason is because most of the time, the reason why people want to merge different data types is because they have one cohort, which is obtained from the demographics, and they want to study only that cohort for the other data types. Like they only want the height for these people, they only want the drugs or the conditions for these people. And so that's why they always want to combine or merge the different data types. Now, I want to point out that, I want to point out that if you are using the tools, which I really recommend, if you are using the tools and you have your own cohort, it's easier to get those because you can restrict the cohort when you build your data set. So for example, let's say I have this cohort, this doesn't matter, but let's say I have this cohort and this is the cohort where age is between 25 and 48. So if I select the cohort and I say I get the demographics and I get, this one is smaller. So I get these two. Note that these are gonna be in two different queries. So let's try and see. So I will show that I'm gonna just put this in a notebook so that we can see. So if we, so if you see, so that's gonna be at the end. So basically you would have two queries resulting from those two, and you have the demographics over here and you have the Fitbit over here. So it's gonna be in two separate queries. So it's not combined by default. So that's where most confusions are coming from, because not only the data types are separated, but we have also this long format. So here I extracted the data. One thing I want to notice that always have the, make it a habit to have this at the top of your analysis, so that whenever let's say that later on we are releasing a new data set, and then your code would need to change, because if you are writing the name of the data set over here, then you have to replace that every time if you move to a different data set, or you are using different data sets. So this, by using this, you don't have to do that. You just run this notebook from start to finish, and whatever data set is your workspace is using, you're gonna get that. So the first part here, just like what I showed you earlier, here I'm getting the demographics, and this is what we have from that. And the demographics, you can check that it's one row per participant, because let's say we can verify. Basically, if you count the number of rows for cohort TF, and it's not Python. So we have that, and if we also count the number of unique person ID, we should get the same number. So here it's saying that we really have one row per participant, because the number of rows is the same as the number of unique participants in that same data frame. And here I'm getting the measurement, and I just filter. I only restrict this to be height and weight. This is height, and this one is weight. So I am getting, and here I'm not restricting to any particular cohort, so I'm getting everything. So if we run this, and we get our data now. Here so the first thing I want you to do is check if one row is equal to one participant for everything. I showed it earlier over here, but basically I'm going through the same thing for the measurement DF and see whether we have the same thing. And based on this, here we have almost 400K, 400,000 K for the number of rows, but we only have 107,000 participants, unique participants. So that means that there are multiple rows for each participant, basically. And since we're gonna do this, like checking one row per participant, I just created a very simple function where I'm just counting the number of rows given a particular data. I'm counting the number of unique participants, and I'm counting the number of rows. So just gonna print. So basically, it's instead of repeating and copy and pasting the whole thing, we just give the name of the data frame, and we output the number of rows and number of participants. And so, well, so then there is a problem, because if we merge this, let's say we want to get here, and if we merge this, so first of all, we don't have body height and body weight in a column. But second of all, there will be multiple, like these demographics. If we merge with the measurements, we're gonna have multiple, this is gonna be repeated across each rows, because one participant, this might have multiple height, and then this gender for this participant is gonna repeat it in multiple rows. So we want to change that, because we want to get in that one row, one participant. So first of all, I think the first thing that we want to do is, and that people want to do, is to restrict the measurements to the cohort that they want. That can be done here if you know the person ID, but say that it's very long and you don't want that. So you can just, what you can do is, so get the participant ID from your, so here we have the demographics. So get the participant ID from there. So this first part is get the participant ID, the person ID. From the demographics, and then we can merge with the measurement. Now we merge it, and in Python, so this is for Python, so you do an inner merge or inner join in R. Basically what this is, the inner is saying that you want the common person ID. So they are merged on person ID, but inner means that you want the common that you find in both data frames. So basically that's gonna, because we have this here in the left, so that's gonna limit the person IDs to people that we can find in the demographics. So once we do that, we have that we have a measurement cohort depth, we have our measurements for our cohorts. And if we count the rows and number of rows and participant IDs, we can see that it's now less than what we had before. So here we had 396, 100, but right now it's 140, 850. And same thing for number of participants, it's reduced, it's 70K now. Before it was 197, 198K. So basically here we restricted our measurements to be only for the people in our cohort. So that's, I think, a very step that people always want, like, how can I restrict to my cohort? So that's how you do it. You merge, you do an inner join or inner merge. Just here, I just took the person ID. I didn't take the cohort ID because I didn't want the demographics to be repeated in here. I only wanted the person ID. If you have any question, feel free to jump in between and ask. I'll stop a little bit if people have some questions based on what I did so far.
I do. I have a quick question, and I apologize in advance if this is a bit remedial. So I've built my cohort, and I'm running my notebook actually right now, and I've tried to join the Fitbit data with other data, and so I have about 6 boxes, let's say, of importing this data in, or loading in the data. It's hard to tell in the code that everything is joined. It's very long code, and so I keep getting error messages when I'm trying to do what you're doing, and I think it's because perhaps I didn't join things correctly, or is that not automatically done from the cohort builder and the concept, those initial steps?
Yeah, the cohort builder and concept sets, they don't merge data sets. So you're gonna get, if you get Fitbit and if you get some other data types, then you're gonna have them in different data frame. Basically, you're gonna get different. So it's not gonna be merged from the cohort builder. Now, one thing when you do merging, make sure that you have the same name for, the same column name. So even if, because from the cohort builder, I think this comes as in capital letters. So make sure that they have the same. So for example, if you have a different column name, so this one, you can turn this, instead of this, you can have like left on and right on. So let's say the name of the person ID was capitalized, the name of the column for the person ID was capitalized for the other one. So this is the left, and this is the right data frame. So in this one, I would just say person ID, person ID. Because if you don't specify like this, it's gonna give you an error because the name has to be the same. That's one thing. And another thing is that I want to emphasize, does that answer your question first, or?
I think I need to just join. I think I can figure it out. Yes, that was very helpful.
So what you're trying to do is joining different data types, right? Yeah.
I just need to rewrite the syntax. The syntax I don't have correctly.
Yes. So one thing also I want to warn is that make sure, because so when you are joining, so imagine, let's say that you have conditions and you have measurements, or you have Fitbit. Let's say Fitbit, because Brandy showed us an example of Fitbit. You have that person ID, and then you have measurements. Let's say your height is repeated also. When you do the merging, that means that for each row of the participant in Fitbit, all the data for that participant in the measurement is gonna be repeated. So I don't know if that is what you want to get. So I usually avoid merging at the beginning unless you're sure that that's really what you want. I don't know if that makes sense. Like for example, in Fitbit, you have let's say 100 days for one participant. And let's say the participant in the measurement, they have 100 heights, different measurements for height. When you do that merge right now, then for each day in the Fitbit, you will get the same 100 height measurements when you do the merge. So I don't know if that is what you want. So make sure that, like I avoid having that merge at the beginning unless it's really necessary, and that's what we want. If you are merging on maybe the person ID and dates, then maybe that will make sense, because now for each date and for each person ID, you have one date and one person ID. So then that might make sense. Sometimes it can be repeated as well, but at least you have both date and person ID. So then it's gonna be it makes much more sense than having just person ID. I don't know if that helped a little bit, but
that is helpful. Thank you.
You're welcome. Do we have any other question? Okay, well, so if there's no other question, I can keep going. So now that we have our measurement for our cohort, and then basically right now what we need to do is having one row per person ID for this measurement. And we're gonna do that in two ways. So first of all, we need to have only one measurement for body weight and one measurement for body height. That's one thing. But another thing is we want to have a column for body weight and another column for body height, because right now they're in different rows. So basically the first one, so here's why Brandy said at the end of her presentation that it's really project specific, and that we're gonna give you some guidelines here, but it depends on what you want. So for example, here, because we want to have only one measurement for weight and one measurement for height, so I made the assumption that, let's say that those body height and body weight are all for adults. That's a big assumption because we need to check what was the age of the participant for that particular date. But if I made that assumption, I would say, yeah, I just need the mean for this height and weight. You can take, for example, the max or median. So that's why Brandy said it's very project specific. Or sometimes you also need the sum. So then what you do is here, I group by the person ID and the body height or body weight. So basically what I'm trying to do is I only want to have one summary measures for body weight and body height. So that's why I have as a group person ID and concept name. And then what I want is for each of person ID and concept name. So that means for this. So here, for this one participant and for body weight, I want the mean or the average of their body weight. And I want also the average for their body height. So that's basically what this is doing. And what we get from here is going to be, we only have for each person and each concept name, we have only one value. So for this person, we only have one value of height and we only have one value of weight. And we can check actually. So remember in here, when we printed the number of rows, number of person ID, we have 70K for participants and about 141,000 for number of rows. And we can see that it's now reduced to 140,522. Same number of participants, but the number of rows have reduced. And this is because we collapsed. We took the average of height and weight if they are repeated. And again, the assumption I made is here that all the height and weights, they are for adults. This is not, because I took the mean, this is not gonna work if, let's say, there is the height for that person when he or she they were 5 years old, because that's gonna skew or affect this mean. And so that's not gonna, so you have to check that and make sure, let's say, oh, I need to restrict only for when I only need the date of measurement when they were above 18 or something like that. So you have to check that. But here I just made that big assumption. Any question for that part before I keep on going? Okay. So if there are no questions, so now what I need is now that I want to have, instead of having this height, weight, I just want to have one column of height and another column of weight. And so that's our last data part of the data wrangling. So basically we want to pivot where we want to have one participant, one person ID. For each person ID, we have one column for body height and we have one column for body weight. And this is, so pivot table in Python, this is basically saying that the index is it's kind of like the row identifier. So I want to have one row per person ID. So that's what this is saying. And the columns, so whatever you have in here, put them as the column names. So that's what this is saying. And then the values, what I want to have inside are these value as numbers. So I'm putting what you have in here are the column names. So I'm saying, what is the row identifier? What do you have for each row? So I have one person ID for each row. And I want to switch or pivot this column, this to be, instead of rows in here, I want them to be in columns. And then the values, to populate that, I want to have these values numbers. That's what we get. So you can see in here that this we have for this person ID. We have two rows. Right now, we only have one row where you have the body height in one column and you have the body weight in different column. And now if you count the number, I think I dropped something maybe somewhere, but this should be the same number of participants, but I dropped something probably somewhere. But now if you count the number of rows and number of person ID, you should have the same at this stage. Maybe I did something, so I'm sorry. This should be 70,000, but you should have now, because we did through all those steps where we reduced we only have one height for each participant, one weight for each participant. And now that we pivot, we should have the same number of rows and number of participants. So that's what we have now. Now that we have one row per participants, we can now merge with our initial cohort, the demographics, because we want the demographics of these people. Now we can merge now where you merge, you get the demographics of these people. Now your cohort, maybe there can be instances where you have more number of people in your cohort than your measurements, because maybe we don't have or the data don't have the height and weights for everybody in the cohort. That can happen because the electronic health records, we don't necessarily have all the electronic health records of everybody. So we have all the survey data for everyone that's in the data, but we might not have all the electronic health records data for everyone in the data. So here, instead of the inner join or inner merge, we do a left merge. We take the cohort, the demographics that have everybody, the demographic data have everybody. Then we do a left merge, meaning that I want to retain all the data that's in here, but I want and then merge only whatever is in here. So sometimes you would have some people, you see like in here, we don't have their height and weight, but we have the demographics. If you do an inner in here, we wouldn't have this anymore, because so it depends on really what you want, but sometimes you want everybody in your cohort. And yeah, if it's let's say if it's null, you can do some imputations, or depends on what you need. But so that's why I put everybody in cohort and I do a left merge. And again, you specify the number, the column where we want to have the merge. So is there any question first before I go to the next thing? No question? Okay, so we now have our data where we combine different data types. So here's what we did. We combined different data types. The demographics and the height and weight. We only, for each row, we have only one measurement. So that's what we did. So the way we arrived there, it was 3 steps. One is we restricted the cohort. I mean, we restricted the measurements to have only the people in our cohort. And then for each measurements, that we're interested in, we took the average value so that we have only one value per measurement per person. So that's what this. And then we pivot so that we have separate columns for each measurements, and we have one row per person. Then we did the merge. So that's how we get there. Another example where it's different is in surveys. So as Brandy mentioned earlier, in surveys, you can have people who answered questions and they checked multiple answers. I think for an example would be gender, I think, where you are able to check different, because in the question it says check all that apply, and people can check different answers in there. So in that case, for the same question, you would have different answers. So here, I just took an example. This is about health insurance. And you can see in here, for example, that for this person, they checked both Medicaid and Medicare. Now, this is different from what we have for, and that's why I want to have this a little bit different from what we had earlier, because this is not numeric. This is not numeric, but this is string text, basically. So depending on what you want again, but let's say that all you want to do is, well, I want to have one row per person, and I want to combine these and just having separate those by comma. So basically that's what I did. So you group by person and then this concept, because this is basically like the height and weight thing. And then the answer, for a answer, I want to combine them, collapse in a sense, and join the two or more rows by comma. So you can see that if you have this person ID in here, so now I have only one row for that person ID, and now the answer is collapsed where you have the Medicaid, then comma, and then this is the Medicare. So that's also a way, but this is for string, because before we did mean, median, we can get minimum, maximum, but that's only possible for numeric variable. And I will stop there. That's the whole presentation. If you have any question or any other questions, please feel free to jump in.
One question. Is this demo notebook will be available to us, or it's just for the presentation purpose?
I was just thinking about that, actually, Francis, if maybe something like this would be helpful for us to add to our featured workspace with just some examples. So yeah, I think this was super helpful to me. So I definitely can see where that could be. So we can definitely add that and flag it for something for us to think about adding in the near future.
It looks like we do have one question in the chat. It says, if the index is not reset, what happens?
I see. So for Python, you have to do this, because if you don't reset index, so instead of having the 0, 1, 2, 3, 4 here as the index, and then you're gonna get that person ID here. Let me run this and show you what I mean. So basically, let's say I don't do this. What would happen is, so instead of having like this is now the identifier for the rows, this would get shifted here. So instead of being a column, separate column, it's gonna be an index. So basically, this would happen. It's even weirder than that. And just let me go in here, because here it's easier. I hope. There you go. So now the person ID is gonna be the index, but by resetting the index, it's saying that, oh, I want this to be because I want it to be a column. So that's why. And you can see that now it's a separate column instead of being an index.
Is there any more questions from the group? Anybody like to add? You can go ahead and speak them out or put them in the chat too if you'd like. Just one. So how similar or different is this process using R? If you want to just speak briefly to that.
Yes. Oh, thank you, Jay. Well, as Melissa said, we make sure that we're gonna put everything, both Python and R, in there. It's similar. I mean, the process behind it is similar. The way to get there might be different depending on what you use. I usually use dplyr, which makes things easier. So for example, this is what I have in R, and it's still the same process. Here I do an inner join. Earlier I do an inner join with the cohort because I want to restrict with the cohort. And then I group by and get the average for the value as number. Group by this, that's what we want. Like we only want to have one height for each person and one weight for each person. And then I want to pivot. So I want to pivot, and we have the index, which is this one, and then you want what you want to be in the column and what you want to be in the value. So it's really similar, just different syntax, but the process is still the same. But yeah, we're gonna put both notebooks in there so that you can see. But it's the concept behind it is still the same thing, and the steps that I took are the same, just the syntax is different. Yes. So the question is, when working with large amounts of data, is there a difference in performance using Python versus R? Yes, there is. Even within R, so R has different packages. For example, I use dplyr and data table. When I need performance, I use data table. The data table is a little bit weird in terms of syntax, but it's much faster, way faster than dplyr. So yes, so there will be performance difference, but I don't think it's huge because both of them should be optimized, and they should fairly similar. If you use data table now, it's different, but between dplyr and Python pandas, I think it's fairly similar. In terms of dplyr R might be a little bit faster, but otherwise there shouldn't be any differences in terms of performance, or at least not huge performance where one is 1 second and the other one is 5 minutes. You shouldn't get that. Another question is, do we have GPU and TPU? Unfortunately, right now, we don't have GPU in the workbench, so that's not available yet. I think we are working on thinking about how to get that in the workbench, but right now that functionality GPU is not available, or TPU is not available in the workbench yet.
Hey, Francis, I just want to point out, I think you did a great job of showing how you go through the steps of having two different data imported. Like you said, when you query data from Fitbit and measurement data, they're going to come in two differently. I like the way you said, make sure to do your cutting down before you merge the two data types. That way your process is a little bit faster later on when you do merge them. You're not, you haven't exploited the amount of responses. So I think that was a great takeaway that I got from this. Looks like we have another question. What graphing or results is available, or am I getting ahead of your presentation?
Thank you, Winston. By graphing results, do you mean graphs, or can you explain a little bit your question? Yeah, sure. I mean, you can do graphs in here. You can do everything that you can do in our studio. I mean, graphing or things like that. You can do in here. So you can show. I didn't show any graphs because that was not really because I wanted to have a different. I had different objectives in mind. But if you're interested in seeing like graphs or something like that, you are welcome to visit our featured or look at our featured workspaces. Basically, if you go, do you still have my screen in there?
Yep.
Okay, so if you go in here, so this is stable right now, but if you go in this hamburger menu and you go into featured workspace, and inside tutorial workspaces, there are a few workspaces that we have right there. And for example, one of them is how to work with how to get started with registered tier data. And you can see that we have graphs, different graphs in there. So you can use any packages that you want. You can install packages if it's not there, but just like you do in our studio, and then you import it. But we have different. So for example, here I think we have only bar graphs, but yeah, you can do mini graphing in the notebook. Does that answer the question, Winston? Okay, you're welcome.
Francis, couple of questions. So this Jupyter, I haven't tried it by myself, so that's why I'm asking it. Is this Jupyter notebook on the workbench? Can I access the terminal through the notebook, or it's not accessible? I can only do stuff within the notebook.
What do you mean? Can you
So
access
the terminal in the sense where the notebook is hosted. So let's say I want to install some package which is not installed through pip, and I have to use some other Ubuntu or maybe Conda commands to install the package. In that scenario, it requires input from the user, yes or no. In that scenario, we usually do it from terminal in normal scenarios.
I see. I've never tried it, although I've never tried it that way, but you have access to the terminal. Let me show you, but I've never tried it. So I've never had to do that. Where is our, if you go, so say you go in here. So once you open your notebook, once you open your notebook, and if you go into file and open, that will give you access to this. And if you go into the right hand side and under this new, you would have terminal. That would open a terminal.
Perfect.
And
yeah, that's what I'm looking for.
Yeah, I've never tried installing things from here, so I don't know. I've never tried it, but anyways, this is terminal, so might work.
Yeah, technically it should. And another question, so is there any specific space to each user in the workbench? So let's say we ran these queries, we clear the data and join the data specific to our requirement. And let's say instead of making a query again every time when I'm running my notebook, I am saving those data frame in some CSV on my instance where I'm working. So is it advisable, or I am not supposed to save any data on my instance, or how it works? Or every time I have to run the query and then join the data and do all those stuff again?
Yes, that's a very good question. And the answer is yes, you can save. Actually, it's really advisable to save your data. If, for example, if the query takes a lot of time to run, or this whole process took you a lot of time, so instead of redoing the whole thing again, saving that final data at the end. And I go through it quickly, but we have another presentation around like workflow where we talk about that. But basically what you do is you need to save your data in what's called in the bucket, which is the bucket for this workspace. Basically, the bucket acts as your hard drive for the workbench. So let's say if we have, I don't know, do we still have this available? Let's see. If we have this. Oh, we still have it. So what you need to do is, first of all, you need to save it. Let's say you save it in the CSV first, and so basically this will save this cohort in a CSV in your local. And again, to find the local, you go here and open, and you can see that that CSV is in here. That's not saving it permanently though. That will save it for, I believe, maybe a few days, because if you are not, I think about a week or so, the whole thing is reset because your instance is released and the whole thing is reset. So you won't have access to this anymore if the environment was deleted and reset. So what you need to do is, from there, you have to save it in the bucket. So we have a snippets for that. We created a snippet for that because that's something that's regularly done. If you go to snippet, and the process is also the same thing for R, but instead of Python, wherever you see Python, it's gonna say R. So if you go into all of us Python and cloud storage snippets, and you go into copy file to from workspace bucket, and you copy data to workspace bucket, that is going to be, let me put it down here, snippets or cloud storage snippets, copy file to bucket. This is going to be, let's name it test2 because, so that people, so this is what this is going to do is this is going to save your CSV file in your bucket, and that is a permanent save, meaning that anytime you need it, you can fetch it from the bucket and get your CSV. What you need to do in here is change, you can do two things. Instead of going through what I did earlier, like saving the CSV, because if you don't need it, what you need to do is replace this by the cohort df, this data frame, and this can be the name that you want, so test cohort. Then if you run this, I believe I missed one step. The first step is going to be, first you need to run setup. So always run setup first, because it's important, some stuff that we need. But if you run this, this is going to save your data in the bucket. And so think of it again as your hard drive. And to check that it's in your bucket, you go again in snippets, all of us Python and cloud storage, and list objects in bucket. And if you run that, you should see we named it test cohort.csv. We have test cohort.csv in there.
And for each workbench, there will be a separate bucket for that, or it's one bucket per user?
For each workspace, there's a separate bucket.
Okay.
I guess just quickly before we end, if anyone has topics or things they'd like to see in a future office hours, if you could let us know, that'd be super helpful. We love planning. And I think, Gage, I just stole your line, so I apologize for that. Everybody, and have a great weekend.
Yes, thanks everybody for joining.
Thank you so much.